All right, so let me address this question on how to do calculations involving multiple phases of the heating curve. So all substances, you can say, have a heating curve. This is Q is heat um, along the x-axis, and that's just at a constant. We're adding constant amount of heat, and the y-axis is that temperature. Um, and so any substance is going to have some kind of heating curve that looks something like this, where you have a slope. This is the solid phase where when you add heat, the temperature goes up. That's very familiar to most students. When you add heat, temperature goes up of the substance. But at this phase change is known as the boiling point or the freezing point. But it's also known as the enthalpy of fusion or the heat of fusion. So all substances are going to have that. And then during the liquid phase, it's going to go through get this back into the, it's going to go through another slope. All right, and that's the liquid phase. And again, once it reaches the next phase change, this is called the um, heat of vaporization or enthalpy of vaporization. In other words, when it boils or vaporizes or condenses, that's another phase change. So it flatlines during that time. The temperature does not change even though you add heat to it, or even if you remove heat, the temperature doesn't change. And then once you have only gas present, then the temperature can continue to rise. Now, substances are not going to have the same slopes. They're not going to have the same dimensions and scales, but they're all going to have this generic part. All right. So, are you listening? I'm answering your question. All right. So, in a question where we ask you to go from like point A to point B, okay, so from this temperature in the solid or to this temperature in the liquid, you're going to have to break this up into multiple parts. So, wherever you see, all right, so generically, the way you want to tackle this problem is wherever you see a slope, okay, so there's a slope, there's a slope, there's a slope. What that means is as you add heat, temperature changes. And so when that happens, we can use Q equals mc delta T. All right, Q is heat right down there. So we can quantify the heat when we're traveling along these slopes. Now we can't use this formula for phase changes because during phase changes there is no change in temperature. So we have to use, right? But there is definitely, look, there's definitely heat involved in a phase change. I mean, you clearly know that you need heat to boil water, or you remove, or in the same case, you're going to require heat to melt ice. This can be any substance. It can be iron. To melt steel, you need heat. Endothermic process. All right, and the same thing is true going the other way. When you condense or when you freeze, these are exothermic, so it's going to give off heat. So there's definitely movement in on along the x-axis. All right, we go with that. So for these phase changes, where I highlighted here in green, you're going to need what's called the enthalpy of fusion down here, also known as heat of fusion, and the enthalpy of vaporization up here, or also known as heat of vaporization. Now you've got to break these up into parts because every every slope is going to have a different specific heat, and the heat of vaporization is not going to have the same value as heat of fusion. So every part, every line on this heating curve, you'll have to break it up into its own little piece. All right, and then oftentimes heat of fusion and heat of vaporization, they give you in terms of kilojoules per mole. So whatever value, whatever mass you have to convert that to moles before you use it. So the short of it is, for these flat parts, these phase changes, you need to get moles. All right, because the unit here is likely going to be in moles. So you get the number of moles, you multiply that by the heat of diffusion over here, you get the number of moles multiplied by the heat of vaporization, and then anywhere you see slopes, you use Q equals MC delta T. All right, and once you do that, make sure the units are the same and add them up, and that's how you get any cumulative amount of heat starting at point A to the finish line. Okay, and if it's going up, it's going to have a positive uh, value of energy, and if you're going down the heating curve, you're going to have a negative because it's exothermic value of energy. All right. So try some more practice problems, and you can keep this up as a reference.